Welcome to our presentation for the World Congress on Sustainable Technologies 2016. Our title is Comparative by Simulating the Eventual Waste Generation of Building Indoor Pavements Construction. Our affiliations are Universidad Politécnica de Cataluña, Universidad Autónoma Metropolitana y Universidad Autónoma de Sinaloa. Currently, one of the biggest challenges facing the planet is chaos-based waste generation and their accumulation in landfills, being the construction and demolition waste the most representative. In a building, different construction phases arise, including the execution of pavements, which are considered as the elements with the larger horizontal surface, being one of the major causes of construction and demolition waste. On this research, the waste generated by three types of usual interior floors in Spain are analyzed, compared, and quantified through simulation. The constructive application was equivalent and with comparable feasibility of use. The aim of this research is to establish and identify which type of pavement generates more wastes, what are they, and what the relationship maintained between them. For that purpose, we use the Net Waste Tools software as a simulation tool. This allowed to us to obtain reports for each pavement type. Finally, these reports were standardized to make a comparison. The results indicated that this type of analysis can perceive differences which have passed unnoticed by the construction sector so far, with an additional contribution to be a new approach that promotes sustainability, environmental care, and financial savings for the construction sector. It is expected that the world population growth will double before the middle of this century. If we take into account the limitations of building areas in big cities, the building sector seems to be forced to define new solutions to this problem. We think that the validation of building systems for sustainable housing could help in this regard. In the United States, building sector represents 38.9% of the primary energy consumption, 38% of all CO2 emissions, and 30% of waste generation. In the European Union, building construction consumes 40% of primary energy, 40% of all materials, and generates 30% of wastes. In Spain, the construction sector produces around 40 million tons of residues, reaching 32% of the total volume. Between the different elements in a building construction, indoor pavements have not been linked to optimization criteria for its sustainable ratification, despite the existing variety of systems and similar constructed solutions. The European Union reports nearly 450 million of tons per year. Only 25% are retrievable, whereas in Spain, it is estimated that 70% corresponding to waste from activities related with the construction and demolition waste. In addition, CO2 emissions in the residential, commercial, and institutional sectors reports an increase of 65% in comparison with 1990. Sustainability on construction could bring new solutions to current society paradigms. One of these could be the establishment of new environmental criteria on the constructive system. The study case is located on a lot of 705.60 square meters, of which 346 are buildable. The building counts with 34 houses and one commercial unit on the ground floor. It consists of a basement, a ground floor, 8 similar upper floors, and an attic. The type apartment has the following distribution of spaces: living and dining room, kitchen, 4 bedrooms, bathroom, and separate WC and sink. The payments of the study correspond to the communal and housing areas. They comply with the requirements of the Spanish regulation. security against the risk of faults, and utilization and accessibility security by the Technical Code of Identification (CTI). According to the selected pavements, you can see in the figure 2 the geometry, its configuration, its materials, and its surface thickness. For each pavement, quantification by square meters of the prices, performance, loss of waste, packaging, and densities used in the simulation were obtained from the database prices of construction generator by the SIPE software. The following tables shows the description of each pavement, indicating specific quantities, performance, and the price of input materials that were used in the simulation, being the P1 a terrazzo tile, P2 a ceramic rustic tile, and P3 a Spanish granite tile. This table shows the main characteristic of the terrazzo tile. We can see the description, the broken down, and also we consider a 10-year cost of maintenance. Now you can see the characteristics for the ceramic rustic tile on this table. Finally, this table shows the characteristics for the Spanish granite tile. This figure shows the results from the Nice Waste tool, partially expressed in percentage of each pavement studied in tons and grouped according to the European Waste Catalog (CER). In all three case studies, the material is always present is the concrete. However, the most representatives are ceramic materials or mixtures thereof, reflecting the difficulty of a single feasible segregation. As a normalization criteria of data, the selected variables were organized according to the size of the tile, the construction cost, and the amount of tiles per square meter. According to the size of the tile, this figure shows the results in different units, for A1 per tons and cubic meters respectively, and for A2 per value of waste generated. These are the results according to the construction cost, and finally this figure shows the results according to the amount of tiles per square meter. In the case of A1, B1, and C1, the waste generated by the P3 are the most volume and weight producer. Also, in the three cases, the standard management produced significantly more wastes when compared with the desirable management. And finally, the unit of cubic meters proves to be the most representative form of measurement. We can see on these three graphs that the standardization criteria that best allow us to discern the behavior is the size of the tiles. You could see that with the highest numerical scale in the vertical axis. In terms of A2, B2, and C2, the waste which presents the highest value varies according to the normalization criteria. For example, for E2 is the study case number 2. For B2 and C2 is the study case number 1. We can consider the amount of tiles per square meter like the most sensitive criterion of normalization of the three cases. Moreover, in all cases, the standard management always generates more wastes than the desirable management. This paper shows that the establishment of waste minimization techniques and an adequate management bring financial benefits for the construction and environmental benefits for the site, because avoid unnecessary materials use and generate less waste during the execution process. This is particularly evidenced by the difference in prices and volumes of the desirable and standard management. Option 3 was the most expensive in terms of management, followed by option 2 and finally by option 1. The cost difference between P2 and P1 is not significant, but P3 is exceeded by more than double the material and construction cost of the P1. In the case of obtaining waste reduction performance, the highest occurred on option P3. In spite of the increase in the value of recovered materials only became to 10%. The study case number 1 generates the largest quantity of wastes, while the number 2 reports the least amount of waste weight and volume. This denotes that the volume and density of materials influence the generation of waste material. Although the Spanish granite tile is a natural stone and Spanish legislation recommends this pavement to be considered for use in any space, in this research it turns out that higher cost is in construction and lower percentage of recovery of materials can reach. But on the other hand, it is the one that gets a higher performance by applying a desirable management of wastes. Moreover, the reduction of the types of waste in a desirable management over an standard management, it is of 37.50% in all cases. It therefore be argued that the application of waste minimization techniques and the establishment of an appropriate waste management will generate economic and environmental benefits, given that the tons of materials intended for landfill, the volume that they occupy, and the cost will be less. Finally, weight and volume of the tiles were the best parameters that describe and allows the establishment of the correlation between different variables, being prescribed like the decision parameter for the final election between sustainable indoor pavements. The authors would like to express their thanks to the CONACYT for its doctoral scholarship program, to the Escuela Politécnica Superior de Edificación de Barcelona, la Facultad de Ingeniería Los Mochis y el Instituto de Apoyo a la Investigación e Innovación de Sinaloa, México.